Y'all are crazy. I was wondering where you were. Whoa. Whoa, bro.
It's too creamy. I actually did all the homework.
Me too. I actually understood it. I was like, I can't even.
Let me see. Let's compare answers. I'm serious. I feel good about it.
Lauren Carey, are you here this morning? You're up here. Start again. Yes. Okay, let me hand these out. Then you can ask. Rebecca C. On these pretests, the score in the box on the main page is your final score.
What'd you post it to me?
I didn't do it in my I just did an equation. Okay.
Malachi.
Yes. Thank you.
Jordan Bates. Sydney Helms.
Oh.
Oh no, it's 6
Sam.
I knew I had to set it
On
up.
the box. That's fine.
I did do these. They're on here.
Lindsay Powell.
Okay.
Maddie Mount. Why did you go girl?
Did we get the same answer?
I can't give it to you.
Alright, Jessica.
Oh, let me see what you did. Did you?
Jessica.
You didn't do what I did. So with these,
Bethany.
how did you determine if these were odd or even?
You know what? It is rocket science.
It's so easy. Okay,
No, it's
like
rocket
X,
science.
if it's X to like an even number,
Yeah.
it's even. If it's X to an odd number, it's odd.
Oh.
What?
I was like, it can't be that simple. Oh wait, it is. This is awesome.
And so for number 11, you just moved everything up to. Okay, so I was doing it right.
Forever to get is that in the stretch.
This one took me forever.
Alright.
What a funny one.
Random
Okay.
Oh, I was watching a video when I was trying to Yeah. Is that the question? Yes. I don't know, what do you say? How do you put it? 1/3, 1/3. Sounds plausible.
Awesome.
Maybe we should put it up to the Mythbusters.
Yes. Can you prove that 2 plus 2 equals 5?
2 plus 2 equals 5. Of course it equals 5. Yeah. I can prove this though. Did you know that this 1 plus 1 is equal to 0? That's true. Did you know that?
In what case? On what ground?
1 plus 1 equals 0? Same thing, 1 plus 1 plus 1 equals 1. You know that? And 1 plus 1 plus 1 plus 1 is equal to 0. You know that? Do you have any computer scientists in this room? Anyone? Anybody?
Oh, this is programming, isn't it?
Wait, I don't.
No?
It's on binary.
Binary. Binary system. Yes. My dad knows how
Anybody's
to do
going to
this.
go into engineering, computer science, anything like that? Yeah, I'm about to start learning that. Then you're just gonna, well, all you really gotta know is this. 1 plus 1 is 0. As long as you know that.
Wait, so if you did that question on the test,
He's not gonna put
no,
it on the
the
test.
answer would be 2. It's just a binary. But in the real numbers, we know 1 plus 1 is 2, right? Does that mean what
okay,
is,
so what's the difference?
what's 2 plus 2 equal?
5.
5? No.
See, I was right.
Binary what? Binary what?
Binary system.
Scientists are trying to prove that 2 plus 2 is 5. I don't know.
I'm saying it's.
I want to know how it's possible.
Not.
It's not this way.
Real. It's not real.
This is weird.
The binary system makes
See
your
your
computer work.
calculators, your cell phones, your computer right here. You know, all this stuff works out of the binary.
Okay, who was that one in that school?
No, it's not going to work like that. Now, if you change the binary mode, and then do 1 plus 1, it'll tell you 0. Anyway, that's the fun fact of the day. Oh, I have another fun fact I heard on the way in this morning. Who knows what the most addictive cookie is in the world?
Chocolate chip.
No.
Sure.
Oh, Hillary, that's what it's named.
No.
Sugar.
No.
Snickerdoodle?
No, not Snickerdoodle.
Wait, addictive? So like.
White chocolate.
Like drugs are these addictive to prejudice?
No.
Marijuana
Your
cookie.
mind is on the wrong. Most addictive cookie, nobody knows?
Nutter Butters.
No.
Oreos?
Oreos.
Oh.
So apparently they did some experiments with lab rats and found out that Oreo cookies are just as addictive as cocaine.
Oh my gosh. Just give all the druggies
Fun
Oreos.
fact of the day. Alright, so you learned about binary, you learned about Oreo cookies. How many people love Oreo cookies? I love Oreo.
I like the vanilla one.
Nope.
You don't like
I
them?
like vacation. Sometimes I like
Okay.
I
Alright,
really like vanilla one.
enough about all that. Alright, we have some homework.
Yes.
3.3. Yes, put it in binary. Any questions from 3.3? Graph translation. 41. I thought somebody might ask about that. 41. Alright. Okay. Alright, so this is a set of transformations we have to do on this function. Alright, so how about the first one here? Reflect about the x-axis. How do we write that? So we're going to do it in steps. Right? So here's the first one. So if you reflect that about the x-axis, what do you have to do?
Negative in front.
Okay, so put a negative in front. Right? Step one. A vertical stretch by 2. And again, we're working on the one above it. So we want to take this now and stretch it by 2 vertically.
Multiply by 2.
Multiply by 2. Alright. Shift it forward to the left. Shift it forward to the left. So what would the final be?
I got this in negative 2 outside of this
Like that? Okay. Everybody see that? Remember when you're doing a shift left to right, it's the opposite sign of what you think it should be. So you think shifting to the left is just subtract 1. Okay. and then we got to shift this thing down by 2. What's that going to do? We shift it down.
-2 times x plus 4 squared minus 2.
Minus 2, right? Alright, so that right there should be the final question. Could you graph this? What's the graph look like? Which quadrant's it in? Which quadrant? Third quadrant. It's upside down parabola, right?
And it's skinny.
And it's skinny, right? Because we did a vertical stretch. Well, it's kind of skinny. It's not. What's the, so how far over is this way do I have to go?
4.
Kind of good.
That's what I got.
Okay. Alright, does that make sense? And you just got to be really methodical about doing each step. As long as you know the rules, then you can. Okay. Other questions? One more. So that's the graph that we're working off on 21. So what we have to do is find this. H x equals 2 of x. Right. So what do we need to do to this graph? What does this 2 do? So this is g of x, right? So what does the 2 out in front of that do for this?
The vertical stretch. I don't know.
Yeah, right.
Okay. Oh god.
Right. So you're multiplying here by 2, just like we did here. So it's the same thing. So how do we actually translate that into a graph that's going to be perfect? So what's this point right here? Let's start from the left and then the right. Let's look at this point. Look at these 4 points. Okay, so this point right here is what? What's the coordinate of this point?
-2 positive.
Okay, so this is -2, 1. What's this point?
-1.
-1, -1. This is 1, -1. And this point is 2, 1. Alright, so what does this 2 do out here? It actually takes the y component and multiplies it by 2, right? So if you take the y component of each one of these points and multiply it by 2, that's what you do with every point.
Oh. Okay.
Okay? Alright, so this point now becomes what? Instead of -2, 1, it becomes -2, -2. This one becomes -1, -2. This becomes 1, -2. And this one becomes 2, 2. Right? Make sense? Alright, so now the graph moves down here. And then it goes up here.
Bless you.
Okay, after that. You can see it. Okay. Okay, other questions on the homework? Anything else? 3-3? Okay, use transformations to sketch the graph. Okay, what is the basic function here is the upper value there, right? What does that graph look like? Yes, it's V, right? Going right through the origin. So that's the basic graph. That's the value there. Okay. So in other words, when x is equal to 0, right, you get 0. Plug it in here. When x is equal to 1, you get 1. When x is equal to negative 1, you get 1. So on and so forth. So in this function, what does this plus 2 do for everything? Does it move it up, down, left, right, inverted? Moves it up, right? Moves it up by 2 units. So now when you plug in x equals 0, instead of getting 0, you get 2, right? 1, 2. Now when you plug in x equals 1, instead of getting 1, you get 3, right? 1, 3, negative 1, 3. Alright, so that's basically all. It scoots this graph up by 2 units.
I thought it was the opposite of the way you thought it would go.
That's for
Horizontal. Okay, never mind.
I thought when you moved it to like the x on the x-axis is on the inside of the whole thing.
parentheses.
Oh, this one.
This is actually value.
Ah, okay.
Right, would you agree though, when you plug in points, well, like we said, when x is equal to 0, you get 2. Is that right? Am I going to do this right or is this wrong? I don't think I did it right either. It is. Okay. So what about when x is equal to negative 2, what do you get?
0.
Oh. Well, when x is equal to negative 3.
1.
Okay, so here we get 0. What do we get for 3?
1.
Negative 3? Where's your plus 1 point? Oh, minus negative 4. Negative 4. Let's do one more over here. Take your time.
3.
I'll go the opposite direction. X is negative 1. X is on that 0. 2. And one more x equals 1. Okay, so you do see here that we have some symmetry going on, right? Around this value x equals negative 2. That's the graph. So what's this one here? What's this other one then?
It would be
Absolute value of x plus
3, yeah.
Let's do that one. Okay, so that's 47. Any other questions? You guys still working that one out in your heads over there? Yeah? Right, anything else out of 3? Yeah, I can, yeah. Let's see, we have some homework correct related to that. 27 and 33.
Was it
Yeah,
really
so
that
let me talk
simple?
about that real quick. We have this idea of even and odd functions. So basically, the even function is a function that if you do f of x equals f of negative x, and you get the same thing out, this is the even function. The odd function says negative f of x is equal to f of negative x. Right? Now this information, if you look back, is on page 190. Right? So, given that, if we look at problem number 27, you give this function g of x is x what's that? So the question is that an even or odd function? So to figure out if it's even, you take, instead of having just x by itself, you put a negative x in for x, and see if you get the same function out. And if you do, you get a function. Okay, so what is g of negative x in this case? So you stick negative x in for x. This is the multiply x. What's negative x cubed? Negative x cubed. Okay, is that equal to that?
No.
No. Those are not even. It's not even.
Can't you just look at the power and say if it's an odd or an even number?
Usually you can do that, but it depends on what's after it, right?
Yeah.
Yes, it can be conversion. So what's negative? So we need to test now negative. Negative g of x is equal to what? What's negative g of x? Is it just negative of this? Negative x is equal to this?
Yeah.
Well, now that looks just like this, doesn't it? But that was g of negative x. Good. Right, are those two equal to each other? Yes, they are, right? So this is the odd function. What's 33? Okay, this is one of those where you can just kind of look at it and figure out what it's about. Right, so the g of x, what is that? What is g of negative x? Negative x. Now it's negative x to the 4, 2. What's negative x to the 4th power? It's x to the 4th. That's equal to g of x. So this is the same place. No, you won't have a case for it. Can we do another example? Oh, 35. Feel that. Alright, so how about this one? So to test for even, we have to plug a negative x in for x. See if we get the same thing out. So e of negative x. What's negative x quantity squared?
X squared.
And put a negative x in here. Is that equal to that?
No.
No, it's not equal. Okay, how about odd? So we've already done this, right, for the odd test. So now we just need to take a negative and stick it out front. So negative, right? You just change the signs of all these things, right? Negative x squared. Is that equal to that?
Yes.
Are these two equal to each other?
Yes.
Yes?
Because you factor out a negative 1. Or multiply everything by negative 1. Because if you take multiply negative 1 times negative 2 of x, and that makes it a positive 2 of x, and a positive x squared plus x minus 3.
You're complicated.
I am? Because it looks like
If you do that, you end up with a negative. You gotta look at the two, the output of both of these and compare.
Okay.
Okay. So these are not equal to each other. So it's not odd. But in this case, it's neither.
You always take the even first and then do the odd one if it's not.
Or if you want to do odd first, it doesn't matter. You can check the odd function first. In either case, you've got to calculate each one of these things, right? Or actually these two things. Because that's what the test is, right? So to find out if it's even, we got to say is the function equal to f of negative x. Okay. So you're doing that comparison with those two. If that doesn't work, then you check this one. If that doesn't work, you will. Well, you're only really calculating three things here, right? Or two things. You're calculating this, and you're calculating this. Right? Because that is that, right? And that's just a given function. That was given to you. So there's no calculating that. That's just given. So you're really just looking at that and that. So we do those two things, and then do the two comparisons, and figure out if it's even or not. Generally speaking, when we have an even highest exponent, that's probably going to end up being an even function. Although in this case, that didn't apply, right? The highest power here was 2 even. But because it has plus x to the odd power, that's complicated, right? But in general, if you've got an even power and an odd power, probably going to end up being an odd function. An even power is generally going to end up being an even function. Again, that doesn't apply. Do we need to do another example of even odd function? Got it? One more? Let's do, top 3. So what is m of negative x? It's like a negative x in here, and you get negative 2x on 3. Is that equal to that?
No.
No. So now we just need to figure out this, right? And what's negative 10 of x?
Negative 2x plus 3.
Negative 2x plus. Now, the odd test is comparing these two. Do these two equal to each other? No. How do I get this? Because this negative sign is distributed throughout this whole thing. Yeah, because it's really just that, right? It's m of x, and then you stick a negative sign out in front of it, like this. So if you distribute the negative through. So the odd test, what does it say over there? Odd function, the negative f of x, which is that, compared with f of negative x, which is that. These two for even, these two for odd. And if I got it, I'm going to do one more thing.
Oh, wait.
Alright. Okay, so that's it for 3.3. Let's go on to 3.4. Okay, quadratic functions. So this is a simple definition here. We have three real numbers, A, B, and C. A cannot be 0 because if A were equal to 0, this function would then become what type of function? If A were 0. Anybody know? That is true, but what would it be? It would be a linear, right? Linear function. Alright, so if A were 0, this would be a linear function. But in this case, by definition, A is not 0, and A, B, and C are all real numbers. So, in that essence, this is called a quadratic function. And the graph of this thing, the graph, say graph 1. And this is just called the general form. So, I mean, we've already done some functions like this, right? The question is this a quadratic function?
Yes.
Yes?
Yes.
What are B and C in this case?
0.
0, right? Alright. What's our graph look like? What's on this one? Another quadratic function.
Yes.
But in this case, we have B is equal to 0, right?
Mm-hmm.
What's that graph look like?
It's shifted over one. No, it's up one. It's up one.
It's up one, right?
Mm-hmm.
What's up with that? This is square plus 1. Alright, you can write, go on and on. With an infinite number of quadratic functions. Why are there an infinite number of quadratic functions?
Because there's an infinite number of points on a graph.
Oh, I thought you were going to say it. Because there are an infinite number of real numbers, right? So because of that, you can create an infinite number of quadratic functions. Okay. Okay, so we have this thing on the vertex. So the vertex form of a quadratic function looks like the following. X squared equal to a x squared plus. That's the general form, or the vertex form of a quadratic function. I'm just going to leave that up for now and come back to it in just a few minutes. Okay, let's look at an example. Another example. Here we have this. Okay. Can we graph this function? You're afraid to? Yeah. Okay, so we have some transformations going on here, right? What's the basic function we're working with?
X squared.
Okay, it's the x squared function, right? Alright, we have some stuff going on here. What does this 2 outside here do?
It stretches.
Stretches, right, vertically. What does the -3 do in here?
to
To that.
Which way is it shifted?
that way.
To the right.
To the
And what does this thing do?
shift it upward.
Good. So you guys Alright, so we have a vertical stretch, we have a horizontal shift of 3, and we have it vertically shifted back forward. So what quadrant does that put us in? 1, right? Okay. So we're shifted 3. We go up 4. Alright, that point right there is called a what?
Vertex.
Vertex. Alright. And does this graph open? Does this parabola open up or down?
Up.
Okay. Why do you know it opens up?
Because it is positive. Well, it's not.
Right. If that were -2, what would it be doing?
It would open down.
Down, right? Okay. So this thing opens up. That. So that's it. That's all I want to do on this problem. Again, I'll come back to this general form in just a second. But yeah, so you have to use graph transformation. From this chapter on, we will use this thing right here to actually figure out what graph is. But from 3.3, we know we can use transformation. So this.
If the choose to stretch it, what would it look like if it was shrunk?
What would it look like if it was shrunk?
It would be negative, so that would make it down.
Right, so the -2 would make it open up downwards, right? So a vertical stretch is if this is,
Inside the parentheses.
no, if it's outside, right, but it's, what's the deal with this number? Oh, so if it's a fraction, what happens? Yeah, if it's a fraction, it stretches it out this way, right? Which I call a vertical shrink.
It's a fraction that shrinks it, and a whole number stretches it.
Right. Yeah, and so if you go back to 3.3, and look, you have that big table.
Yeah.
There's a big table in there that talks about the different transformations. You'll see that if this number here is a fraction, so between 0 and 1, then it actually vertically shrinks it.
Okay.
So it won't ever be shrunk very much. If it's a fraction.
Right?
If it's
What if this were 1 over 1,000?
then that would be a lot.
That's a lot of vertical shrinking, right? So instead of it looking like that, it's going to look like this. It's a big fat smile. Basically, right? If that were 1 over 1,000. Any other questions about that? Okay, so I'm going to come back now and just look at this one. This is something too you need to commit to memory. You need to know this. This will be on the test, the next test. You need to know what to do with that. Alright, so we're going to talk about the graph of this thing, just the general graph of this. Okay. Okay, so let's talk about a couple things here. So in this parabola, you'll notice we have an H and a K, which comes directly from the circle form. This thing right here is called the axis. Symmetry. Why do you think that's called the axis of symmetry? Right. So if you took this parabola and folded it over on top of itself, it would go directly over, it would fold it across this line. This vertical line, which is x equals h. Now notice this h value is the opposite of this thing in here. So if this were x plus, let's say 3, okay, so your axis of symmetry would be x equals -3. It's the opposite of what this is. Okay. So we have a couple things here. One is vertex, H, two, the axis, symmetry, H, 3, H, K, So f of h equals k. So this is our function. F of h is just x value. So I say f of x. So that value is actually k. So that's where this comes from. So f of h equals k is minimum if a is greater than 0 and the maximum if a is less than 0. So why is that? So it says if a is positive, right? So this value, this k value, is the minimum of the graph. Anybody understand or know why that's true?
Because I'm at the bottom. It's the lowest one in the graph.
That is true. Remember, if we go back to this example, we said because this value is positive, what does it mean about the graph? It opens this graph up. If this were negative, it would open down. So if this is positive, that means it does something like this. This means that's a minimum, right? That hk value is a minimum. That's what this is saying. So if a is positive, it means we have a minimum to this point. If that's negative, it means it opens downward, okay, like this, upside down U, which means that that's the maximum. Okay. What else I want to say about this? What's on the domain? The domain is a set of all real numbers. And the range is the following. A is less than 0, or k to infinity if a is greater than 0. Okay, again, let's look back, say this example. So in this case, a is this number 2, right, which is positive. So that says that the range of this function goes from that point k to infinity. Well, this is the point, this is the h value, right? This is the k value. So in this case, because a is positive, it means we're opening upwards, so the range is going to be from this value k up this way to infinity. And that's what that means. Otherwise, if a is less than 0, again, that means this thing opens downward, like that. So this value k, or the range then, is going to be negative infinity up to k. Negative infinity up to k. Okay, so here's the problem. That's nice. Alright, so what we want to do here is find the vertex form for this function. And we know this is a parabola, right? We know it's a parabola because it's x squared. And so we got to figure out what's the vertex form of that. Well, here's the vertex form, right? We have to go from this to something that looks like this. And because this thing is squared like this, that indicates that we have to actually complete the square out of this. You guys remember completing the square? Yes, unfortunately, you remember that? Alright, so here's how we do this. We're going to sort of isolate these x terms together. We're going to factor out 2 first. 2 times x squared minus 4x plus. First step. You can kind of already see, right, even right here, that we're getting this thing to look like this, aren't we? It's starting to look like that already. Okay? So we have the 2 on the outside. We know that's going to, what's that going to affect? What's that 2 affect in the final vertex form?
Whether it'll open up or down.
Up or down, right? And also if it's vertically stretched or straight, right? Okay, so that's what the 2 does. So now we need to complete the square on the thing on the inside of these parentheses. Let's just do x squared minus 4x Okay, so to complete the square here, we take half the middle term, which is -2. We square it, right?
Mhm.
And then we do something else with it. When you square that, you get what? 24? Right. So in completing the square, we were like solving for x. We usually have this constant term on the other side. And what we did with this is you took half the middle term, you squared it, and you did what to both sides?
You added it.
Added it, right? So because we don't have anything over here, it's over here, we're actually going to subtract it. So we're not going to subtract 4, we're going to subtract 2 times 4.
Say that again for me.
And when you're normally completing the square, right, you're trying to solve for x, right? X
Right.
equals something. So when you do that, you have a value over here, right? Like some constant.
Right.
So when you complete the square, you take half the middle term, in this case it's -2, you square it, which is +4, so you add 4 here.
Mhm.
And then you also are supposed to add that to the other side, right?
Yeah.
But because we don't have anything over here, we subtract it on this side. But we're not subtracting 4 because you can't do that because we have 2 on the outside. It's 2 times 4, which is 8. We subtract 8.
I got you.
Makes sense now.
Does it?
Yeah, it does. I get it.
So now this is 2. Now, this is a perfect square, right? Because we complete the square. So this is x, perfect square. What goes here? Always, always, always. Remember that? What goes here?
Half of the
Half
middle.
middle term, right? And then we have this. Now, we have this in the exact form of this, don't we? They look just alike, right? Is this not a x minus a squared plus k? Okay, so we're done, right? We found the vertex form, and this is your answer. Okay, so what is the vertex for this parabola? What's the vertex?
-2.
Negative.
No, +2, -4.
2, -4, right? What's the axis symmetry? Give it to me in an equation.
X equals -2. No, +2.
Okay, to get your axis, you just have to look at the vertex. Right? This is the vertex of the parabola, right? That means 2, -4. There's our vertex. We know this thing opens up, right? There's your axis symmetry. This is always the h component. That value. So all you have to do is read it directly off of here. Once you have the vertex, it's always the first one of your axis symmetry. I'm assuming you guys probably will do another one of these. Oh yeah. Before I do that, yeah. Okay, so this is our general form, right? So the vertex is h. Okay. Just write it down. It's not negative because the general form is negative. Okay. So as long as this comes out to be negative here, we can fix by h is equal to 2. If this were x plus 2, then this would be -2. So x value would be -2. What's the domain of this function? Domain? So it's instead of all our numbers, what's the range? -4 to infinity. Does it include -4 or not? Yes. This is, I really just sketched the graph. So this is what it looks like. So there's your vertex, right? And 2 times -4. We know it opens upward, right? Because of the positive on the outside here. So the range goes from here up to infinity. So that value right there is K. This is K value, which is negative. The range is negative 4. The next of all of them. Okay, let's do another a little bit more. Negative 0.5 minus -0.2. How about this one? So again, we're going to find the vertex form of this parabola and a couple of other things. Okay, so how do we do this? We're going to treat it the same way as we did this one. So we're going to isolate the x values together, the x terms. We're going to factor out whatever's in front of it. Right, so this is negative 0.5 times x squared plus what? What goes right here?
0.5.
What?
0.5.
0.5? No.
Because there was a 1 in front of the x.
There is a 1 in front. But remember, you're multiplying. Right? So 0.5 times what is 1? 2, right?
Oh!
Everybody agree with that?
Yes.
Where'd that negative x go? Did that become the 2? Is it?
This is negative?
Yeah, the negative x.
I factored it out, right?
Oh, okay.
Right.
The
So
x.
negative 0.05 makes that a negative.
Okay, what about the x?
Same thing.
Okay.
Oh, no.
Is it 2x plus
Is it
2x?
2x?
Yeah.
Okay.
I was panicking
That's what
for
you're saying. Where
That's
the
what I was asking. Where'd the x go?
Yeah, the x is
Okay.
it's right there.
Okay.
Okay. So now we have that. Right. That's basically the second step. Something in here. All right. Now we're going to complete the square. X squared plus 2x something plus 2 something. All right. So what goes right here is the question. Again, completing the square, you take half the middle term, you square it. Right. So plus 1. Okay. But we're not going to add 1 over here, are we?
Subtract.
Okay. We would subtract it. However, in this case, we are going to add. Because we have a negative on the outside here.
So it's plus 0.5.
Plus 1.
Why 80.5?
Because it's 0.5 times 1. Right, same thing over here. We didn't add 2. Well, we didn't add 4. We added 8. Because it was 2 times 4. Right? That's the opposite. Right? Okay, is everybody with me down to this point?
Yes.
Ask the question if you're not.
So one.
Okay, why are we adding? Okay, why are we adding the 0.5? Okay, you see how we got this, right? Half middle term is 1, squared is 1. So in a normal completed square scenario where you're trying to solve for x, you would add 1 to both sides. Okay, but here we're not adding 1. We don't have anything over here, so we have to first of all subtract 1. But it's really not subtracting 1 because we're multiplying this 1 by a negative 0.5. So the negative times the negative makes it positive. Right?
Oh. Okay. Yes. Okay. I got it. Cool.
This is x plus what is here? 1 plus 2.5. Okay, we're finished? We have it in vertex form? We do, right? Okay, so what is our vertex form? Vertex of the parabola is what?
Negative 1, 2.5.
Negative 1, 2.5.
Somebody said that already. Who said it?
Right?
And then
What's the axis of symmetry?
negative
Negative
1.
1. X equals negative 1.
X equals negative 1. Again, that comes right from here. Alright, well, so graph the function to find the minimum and maximum of the domain range and increases or decreases. So what does the graph look like? Our vertex is at negative 1, 2.5. There's negative 1, 2.5 is right there. Does this thing open up or down?
Down.
Down. up is down because we have a negative out here, right? And this is really negative 1/2, right? So what does the 1/2 do to it? Is it vertically stretch or shrink?
Shrink.
Shrink it, so it makes it faster. Now, I'm not going to draw this scale. And there's our axis of symmetry, right? That's x equals 1. So what else do I want here? What is the domain of this thing? What's the domain? Real. What's the range? Negative infinity to what? 2.5. Is that open or closed bracket here? It includes the value, right? What's the range? What is the domain range? It says find the maximum and minimum of that x. What's the maximum of the function? It occurs here, right? Okay, so that's the max value. X equal, that's perfect, right? So x is negative 1, it's 2.5. That's the maximum. What's the minimum?
Negative infinity.
Negative infinity. Okay. Down from there.
I have a stupid question. Why is the domain all the numbers? Because it goes on for infinity?
What does the domain represent? What set of?
It's all the x values.
It's all the x values, right? Now, the way I drew this, it kind of looks like that curves back in on itself, but it doesn't.
It goes out.
Really, this thing goes out like this. It keeps going out like that.
So did you say it was also negative infinity to positive infinity? Would that be the same as all the numbers?
Yes, it's the same thing, right? So negative infinity to infinity. Always. Then it says, what are the intervals over which f is increasing? So when is a function increasing over what interval? From what to what? This thing is increasing.
Negative infinity to 6.5.
Infinity to x values.
Negative 1.
Negative 1. Okay, so where's it decreasing?
From negative 1 to
Negative 1 to Alright, so that's, okay, you guys want to see another example of this? Yes, no, maybe. Yes, we have one yes. We have one yes. I think we need another one. Okay, let's see. Alright, so let's just get this into vertex form and find the vertex and the axis. Vertex and the axis. Alright, first step, we're going to factor 1 out. This is x squared w minus 4x plus 2. Because of the negative. So you're going to do this over here. Factor out a negative 0.5. We want to get this x squared value to be positive. So negative 1 times x squared times x squared. Negative 1 times negative 4 is positive. Alright, next step, we do the old completing the square thing. Alright, so this is x squared. Half the middle term is what? Negative 2 squared is plus 4. So what's going to go over here?
minus 4. Minus 4.
Is it minus 4 or plus 4?
Minus 4.
If you add the 4 to the other side, then subtract it back over.
What? Why is it plus 4?
Yeah, when you have a negative out here, that affects.
But it's the negative.
Doesn't the 4 become negative though?
Yeah,
Because
because
it's inside the parentheses?
No, it's a positive.
So then you would subtract 4 from both sides, but we're not doing, there's nothing over here, so we're actually adding 4.
It's like that other one we did.
Just like this one, right?
Oh, for some reason I thought we subtracted. Okay, never mind.
Alright, so this is -1 times x squared. Alright, what goes in here? -2, right? It's always half the middle term. Always half the middle term. Alright, so what's the vertex?
Two, positive 6.
6. Axis.
2.
-4, half of that would be -2, but since the 4 is negative, we're going to get positive.
Right here?
Yeah, because that was minus h and it came in a -2, would it negative minus negative be positive?
Are you saying this should be positive?
I don't know, because,
No, it shouldn't, because this thing right here breaks out to x minus 2 plus squared.
oh, okay, so you work that out and go back into that. That's
Yeah, I
right.
mean, you're just really working with the inside of brackets here.
Okay.
So x minus 2 plus squared. Right, if you square that out, that, right?
Yeah.
That equals x squared minus 2x minus 2x times 4, which is x squared minus 4x equals 4.
Okay.
Yeah.
What happened to the negative? And in the vertex, does it become a positive 2 or negative 2?
Remember, what's the general form? X, up here, general form. Does that look like that?
Yes.
Yes. So that H is a positive 2.
Okay.
That's the general form, x minus H plus K.
Okay.
Any other questions? You guys got a handle on this? What is your next test? I'm not sure. It'll be, it's definitely won't be Monday. It won't be next Wednesday. It'll be a week after. Okay, you guys have any other questions about vertex form? Any other questions? No? Okay, I think I'm going to stop there today, and we got to do one more thing before you guys leave. So they handed out these little mid-semester feedback forms for your teachers. Do I expect you to take these seriously? It's up to you. If you want to take it seriously, you can. If you don't, then just put some smiley faces on it and turn it in. Or draw a picture, or whatever you want to do. So what's going to happen, I'm going to hand these out. I'm going to leave the room. And can somebody volunteer to collect these? And I don't care.
It's volunteering me.
You're going to volunteer? Okay. So when you're finished with them, give them to Madeline. Okay. And do not write your name on it. Because if you write, because guess who these go to? Me. So I'm going to read these and it's supposed to be feedback for how you guys think I'm doing, I guess, in mid-semester. Which I did it to my other class and I read them. Well, I'm not going to say one of the because you guys might write the same thing. I'll tell you after. So it's up to you if you take this serious or not. I mean, it's supposed to be feedback. I'm not going to give you homework. So you guys are.
No, he wants us to give him feedback. That's the whole, and then you have to. Alright, nobody put aside homework on.
Okay, thanks.
bring brownies to class. Brownies. Everybody put bring brownies to class is something you want them to start doing.
Brownies.
Brownies.
Bring brownies to class.
Bring brownies.
Give me mom.
You didn't give me one.
Yes. No, I don't know. Okay.
Okay, I'm leaving the class, so you guys go ahead and get
Can I have one?
those.
Can I have one? Huh? Okay, thank you.
All right.
That'll work.
Are we going with brownies?
Everybody right now is
bring
Start doing bring brownies.
What are you writing?
Bring brownies.
Teaching us.
That's fine.
It's Monday.
You know he's gonna be reading them.
Whatever. And then I'm gonna draw him a pretty picture to make up for Mike. Not for my
You said brown. Brown. They are already in items.
I'm drawing.
Questioning when I actually answered it correctly.
Don't say that. It's gonna sound like a song.
Say it.
Matt.
I have a pretty picture to make up for you're not doing
It's confusing.
I'm not gonna say anything to stop this.
Okay, I'm not either.
Alright. That was out early. What did you say this about? Don't be mean. Yeah.
Pretty
Enjoy her flowers.
I need the giraffe.
We'll stop this.
Please. Everybody put bring brownies. Everybody. Maybe he'll actually bring brownies.
Everyone has to work here.
Bring brownies. Maybe he'll do it.
We all protested on class time, they'll change it.
He can't, he doesn't have the
Can't
power.
change Who am I supposed to give this to?
Make it sunshine.
It's looking nice.